And we're going to use two types of signals in this case. We're going to use a start sequence, and we're going to use a stop sequence. Now, a stop sequence is a hydrophobic sequence similar to the start sequence, but what it does is it tells the translocator to stop translocating. It doesn't tell the ribosome to stop translating, it just tells it to stop translocating. Okay, so go ahead and stuff this back in your, and you want to do the same thing, just kind of have this poking out.
Okay.
So what's going to happen here is we're going to have two signals. We're going to have an N-terminal start transfer sequence. That's going to get the translocation process started. Then somewhere in the middle, we're going to have a stop transfer sequence. Okay? And now this all occurs the same way. We have the ribosome, we have the SRP. They're just not showing the SRP. Okay? But understand that it's still there working in the background. Okay? So I'm coming along. I see the start sequence. What I do is I'm going to insert it with the N-terminal facing the cytosol. Okay? We're going to, still translocating, and go ahead and bring this out. Here comes the stop sequence, right here. And so that's going to insert, and now I'm going to stop translating, okay, or stop translocating. But I'm still going to continue translating, okay? So now I've got part of it still out here in the cytosol. This would be the C-terminal, right? And I've got this part here, which is the N-terminal. We get our signal peptidase because if it's on the N-terminal, if that signal sequence is at the N-terminus, then it gets cleaved, okay? Now, I've got my N-terminal is in the lumen of the ER, and my C-terminal is out here in the cytoplasm. Make sense? Not make sense?
Is that something that's then going to stay in the ER? Or can
Yes,
it go anywhere
yeah,
else?
yes. So this will stay in the ER, okay? Now this one here, the start sequence, it just gets degraded. So let's go and take that out. That just gets degraded. But this will stay.
So it can't go to like the Golgi or...
Yeah, it can. But what's going to happen, yeah, this entire, it's going to maintain this orientation.
Oh, okay.
And so the other thing I want you to kind of think about is when this gets to the cell membrane, okay, it's going to essentially look like this, where the N-terminal in this case is going to be out in the extracellular matrix, and the C-terminal is going to be in the cytoplasm. And that's a point I want to make because whatever, it's kind of like the what's in Vegas stays in Vegas, whatever's in the cytoplasm stays in the cytoplasm no matter where it's at, whether it's in a vesicle or a Golgi or the cell membrane. Wherever the C-terminal ends up in the ER, or sorry, so wherever it ends up, that's where it's going to stay as far as the cytoplasm is concerned. Make sense? Okay, all right.